I'm trying to keep standing here, so am I loud and clear? No, a little bit. Well, I'll use the other one. Thank you in the back for the suggestion. Welcome everybody to my talk on software architecture and the use of AI while doing architecture. I'm Marcel Schutte. I'm a lead solution architect at Schutte, a large consultancy company servicing all kinds of customers. For me, it's mostly government work, but we do all kinds of industries. In the 20 years ago, I started out at Schutte as a Java developer, and from that start on, I worked a lot with a very different range of architects. In those years, especially in start, it was very much like this. Architecture was done from the ivory tower, creating very big designs, creating a lot of documentation, stacks and stacks of paper. But now, in those years, it changed. We get more new technologies. The release cycles become faster with the whole new agile, Scrum, DevOps. And architecture changed from being in the ivory tower to being way more connected to the development teams, way more feedback loops to create better architectures. Well, let's get straight to it. I really like using AI in my work. I'll stop touching my laptop, I guess. I really like incorporating AI in my work because it can really solve, help me with the more boring parts of my work as an architect. I'll show you how I do that a little later on. I'll even do some live prompting, so I hope everything will be all right. For me, at the core of architecture, we have the three pillars. The diagrams to actually show the vision I want to convey to my client. The documentation to actually show what we've done and why we've done it. To me, the most important part is why. Let's see. Diagrams. I like to create diagrams on different levels because I have to convey my idea to upper management, but also to the developers. And I don't want to create diagrams every time again and again. So I'm going to use a text-based tool for this, and we're going to have a look at it in a moment. For documentation, I like to keep it small, with mainly just the context in which a decision was taken, and in just keep it small and make sure everything is in the context that you want to keep at hand. And the fitness function is to make sure your architecture decisions keep your integrity of your architecture, to make sure it adheres to your principles that you've set at the beginning. And they also make it possible to guide your evolution of your architecture. I use these three tools for this. They're all text-based. The C4 model. Any hands? Do anyone you know the C4 model? Are you creating your own diagrams, or are you creating a model in? Well, no. Every step is a new diagram. Okay. I'll show you a nicer way to do that. ADRs. I really like to use ADRs to create documentation for my architecture. making sure it captures the context in which the decisions were taken and also what other options were discussed but not used. And as a fitness function, there are a lot of ways to do fitness functions. For this particular instance, I would like to focus on ArgUnit. That's a Java-based framework. You also have it for different languages. You got it for JavaScript, for .NET. But for me, ArgUnit is a unit test framework that actually tests your architecture. That makes sure that the architecture you design is created within the application. So we'll have a little look at that later on. These three things are actually perfect to use Gen AI for, at least to get a starting point of your different diagrams, ADRs, and the ArgUnit code. Because, for C4, you got a DSL, a domain-specific language. ADRs, there are clear templates for this, so you can use those as well. And for ArgUnit, it just delivers code, which makes it a very good way of using LLMs, because they're all text-based. Well, little case study. We're going to create something for a pizza restaurant, Italian restaurant. Small business, and it wants to optimize its online ordering process. Current website is outdated and cumbersome, resulting in customer frustration and loss of potential orders. We're going to create a small architecture for this to create this basically a web shop for this pizza restaurant. And some extra criteria. Once a user-friendly ordering application that simplifies the ordering process and increases online orders. All right, here are some prompts. Before I go into what the prompts actually do, at first I used ChatGPT for this. I've switched to Claude for now. Because in my experience, Claude delivers better results when prompting for code or, basically these tasks. I want to give a little disclaimer. I keep it really general in this talk, and also in my work if I use an online LLM, because you don't know where your data is ending up. So keep it general. Yeah. Keep it general, and just fix it afterward. Well, first, let's have a look at the first prompt. Just give it some, this is for now, just to give it a little context. I'm a software architect working on developing new software architecture. I need help creating high-level structure that includes key components, their responsibilities and interactions. Can you guide me through this step-by-step or provide suggestions tailored to modern best practices? And also, I like to keep asking nicely because, I've seen Terminator 2, so. Let's see. We can come over here to Claude. We have the same prompt that I just to give it some context, and now, all right. Oh, he wants to help me. That's nice. He already is working really hard. And that's now I'm going to tell him what he actually. Given it, we're going to give it a little bit of context of what I'm actually want to create. Let's see. I'm designing an online pizza ordering tool for a local pizza restaurant. And just some basic functionality of creating a menu and to place orders. The staff in the kitchen needs to know what they need to bake, what they need to make, and also the delivery drivers need to know where they have to take the pizzas. Just a little bit of info about the techniques I'm going to use. I chose the ones I know best, so I chose Java with the Postgres database. And I've actually left the front-end technology open for later the decision. And I've asked him some questions for this. Let's see what he's going to do. Let's see. He's creating all kinds of things. I really like to use this as a he does a lot of work already. I really like to use this as a brainstorming tool in the first instance, just to get an idea of what would be the best thing or what would be alternatives to what I've already thought about myself. So that's also why I said in the first part, AI won't replace architects, just the architects using AI. Because you get better decisions, you get more, well, you have considered more options than just going to create whatever you created in the project you did before that. Because you are, really, okay. Well, it's done. It's already created a lot of things for me. Just I'm not going into the whole brainstorming part right now, but it already created this a lot of information. Some of the services you're going to need, the way you need to talk to your database, your authentication, and from this part you start. Just start a conversation at every topic that you actually want to discuss, whether or not it's the best decision or not. Afterwards, hopefully you'll have a great an architecture, the start of an architecture that you can use for your system. Now, I've told you just about the C4 diagrams and the ADRs and the fitness functions. Let's have a quick look at the C4 diagrams, because for the people that don't know the C4 diagrams, they are diagrams that zoom in, that are able to zoom in on every level of your application, starting with the context diagram at the highest level, just to get a feel of your whole context of your system. And you can dive into the well, every level below that gives you a little bit more detail of your system. Up until the fourth layer, which is actually the start of UML. Basically, those are only my experience only used by developers at this point, and the other ones are throughout the organization. And because I've told you already about the DSL, that makes it reusable, because you create a model of your architecture. You don't create the diagrams. What you actually do is you create text-based your model. You actually add your actors, your systems, your components of those systems. You give them a name, give them some explanation on what they are actually doing. And in the next part, you're going to connect those entities, basically. So what I've heard a lot lately is that the architects just draw boxes and lines. These are the lines, the ones we saw before this were the boxes. And just by adding these three, well, these are actually the diagrams, because what I've just showed you, these three, this one and this one combined with these three views, actually give me these three diagrams. They are automatically generated from my model. So if I get my model well, completely filled out for every component, you can actually create your diagrams by itself. which makes it really easy to actually reuse your model. And it also, because it's text-based, you can easily add it to your Git repo and make it version controlled. And well, let's have a look if Claude also can help us with this. Let's see. Before I paste it, I want to create a C4 model using Structurizer. Structurizer is the tool actually that creates diagrams from those instructions you put in your in the text file. I want a context diagram, I want a container diagram, and a component diagram. Those are the first three abstraction layers of C4. The context being the less detailed at the highest level, and the component diagram with the most detail on the lower levels. And I'm asking it to actually create structurized compatible text, so we can actually generate those diagrams. Let's see. Same question. Let's see. Well, we've saw. Actually wants to help. That's cool. What he creates here is he creates the different actors: the customer, the baker, the driver, the pizza system at the top level, containing all kinds of subcomponents, and then it actually gives us some explanation on what it created on the right part of the screen. Now I'm not going to copy this. I've done this this morning, and it actually looks like this. This is Structurizer, and it gives me all these diagrams based on the text that the Claude just generated. Basically, highest level, we got three actors: our system and some external systems, a payment gateway, and a map service for the delivery drivers. Well, this is what is generated at first. I really want to tell you to make sure you check what it creates, but it is a really good starting point. You get a lot of your model already done. You just have to fine-tune it to your actual use case, and as soon as you change your model, your diagrams will also be updated. So you don't really need to make your diagrams always up to date. And I know how it usually goes. Architects create diagrams, they put it on Confluence, mostly, and then just leave them there. In this way, you can actually automate it and make them updated as soon as you can put it in your pipeline, and make sure they are updated at the point when you're actually doing changes to your architecture. This is the highest one. This is just one level lower. You dive into your pizza ordering system with a web application, a staff portal, driver mobile app, because, well, they're on their motorcycles and just have the app to where they have to take the pizzas, and a little bit of extra detail on how your system is created. And afterwards, you get actually, for every service in this, you get a little bit more detail. API gateway. Oh. All right. Let's have a look at architecture decision records. These are actually the ones, the records that we keep to make sure that in the future we still understand why we made a decision. Because what we put in ADR is why we did it, not how we did it. No, it's why we make the change that we want to make. You give the several options you had discussed for the particular problem. You give your context what the problem is, and in the end also the decision you've made. I really like to use a template for this. This is a template I got from adr.github.io. They have two different ones, a small one, a minimal one, and a little bit more, a bigger one, with more options and more sections to fill with your decisions. Let's have a little look at this. You have done your architecture work. You're moving on to somewhere in the development stage. Your Postgres SQL database isn't fulfilling what you want to do, so you change. You need to change to a different database. Well, we are modifying our architecture to use Microsoft SQL Server as the database instead of the current solution. Could you draft an architecture decision record explaining the rationale, alternatives considered, and the implications of this decision? And please format it in using the attached template file for consistency and clarity, which means I'm actually going to give Claude a template I want to use for my ADR. Once again, a flat text file. I started out as a developer. I love flat text files, so. It's really nice, version-based and stuff like that. So let's have a look at this one. And then I'm too fast because I forgot to add my ADR. So we're going to see the difference when I actually give it a different. Thanks. I have these two templates, a minimal one and I want a minimal one because I've seen how much text it's generating right now. And do it again. And it's actually going to use my template, which is the template I use all throughout all my projects, and it just keeps it more. More like it. Just the basic start, you give it the context, considered options, decision outcome. And also here, you change the parts you want to change, but it gives you already a nice starting point. So it's really in a way that you use AI as an assistant and not as someone that's taking over, because in my prompt, I can't give the complete context of my problem, so and define nuances of the problems. So, but it's a good starting point. Well, let's have a small look at ArgUnit. ArgUnit is a utility that actually makes sure your architecture in your project adheres to the one you've designed. Let's have a little look at this one. This is a very basic three-tier layered architecture. Basically saying from you can only move the exit is only possible from top down, and you can only move one level lower at a time. So from the controller you can only go to the service layer, and from service layer only to the persistence, and you can't go back up or skip a layer of your architecture. Well, what it actually needs in ArgUnit, it just creates a unit test. You define your different layers. This is the first part, and then you just add a few rules to it that you can't access from one side to the. This is an example of this one. I've also created an architecture just now in Claude. It still knows what we created. So what I'm going to do now is create some ArgUnit test code to make sure I can test my architecture. So I would like you to write ArgUnit unit tests for the architecture we just designed. The test should enforce key architectural rules such as ensuring specific dependencies between packages or layers, validating that servers adhere to naming conventions, restricting certain components from accessing unauthorized layers or packages. Please make the test comprehensive, easy to extend, and aligned with Java best practices. Now, let's see what he creates. In this way, you can already, as soon as you start creating your architecture, you can already send the unit test to the development team, and so they can actually put those in the test set. So right from the start, you get a good sense of whether or not the right architecture is used in your project. Well, it creates a very nice test set with, well, I think 15 tests or something. And it also describes what you're doing in those tests. These are basically the 3 ways. For now, I use AI in my day-to-day architecture work. Let's see. I hope to have shown you a little glimpse of how I use it. And I also think, the way I use it, AI won't replace my job, but it really enhances what I can do and how fast I can deliver my first design. Thank you.